Optics and optical instrument. Introduction. Nature has endowed the human eye retina with the sensitivity to detect electromagnetic waves within a small range of the electromagnetic spectrum. Electromagnetic radiation be- belonging to this region of the sco- spectrum wavelength of about 400 nanometer to 750 nanometer is called light. It is manually thought light and the sense of vision that we know and impact the world around us. There are two things that we can intuitively and mention about light from common experience. First, that it travels and with enormous speed, and second, that it travels in a straight line. प्रकाश जो है सीधी रेखा में गमन करती है. It took some time for people to realize that the speed of light is finite and measurable. It's definitely an accept value in vacuum is a 2.99792458 into गुणा 10 पर पावर 8 मीटर प्रति सेकंड. For many purpose it suffix to taxi बराबर 3 गुणा 10 पर पावर 8 मीटर प्रति सेकंड. The speed of light in vacuum is that highest speed highest speed attainable in nature. The intuitive notion that light travels in a straight line seems to contradict what we have learned in chapter 8, that light is an electromagnetic wave of wavelength belonging to the visible part of the spectrum. How to reconcile that two facts? The answer is that the wavelength of light is very small compared to the size of ordinary and objects that we encounter communally and generally of the order of a few centimeter or longer that we encounter communally. And in this situation, as you will learn in chapter 10, a light wave can be considered to the travel from one to one point of another along a straight line journey. A reflection of light by spread Kumar. Mirror. We are familiar with the laws of reflection. The angle of reflection, that angle between reflected ray and the normal to the reflecting surface or the mirror equals that angle of incidence insides and angle between incident ray and the normal. Also that be incident ray, reflected ray and the normal to the reflecting surface at that point of incidence lie it the same plane. These laws are valid at each point on any reflecting surface, whether plane of curved and however we shall restrict our description to the s- special case of covered surface and that is spherical surface. The normal in this case is to be taken as normal to the tangent to surface at the point of incidence, that is the normal is along the radius the lines joining the center of curvature of the mirror to the point of incidence. We have already stated that the genometric and center of a spherical mirror is called its pole while the of that of a spherical lens is called its optical center. The line joining the pole and the center of curvature of the spherical mirror is known as the principal axis. In the case of spherical lenses, the principal axis in the classical lenses, the principal axis is the line joining the optical center with its principal focus, as you will see later. Sign convention to drive the prevalent formulas for reflection by spherical mirrors and reflection by spherical lenses. We must first adopt a sign convention for measuring distance. In this book, we shall follow the Cartesian sign convention. According to this convention, all distances are measured and from the pole of the mirror of the optical center of the lens. The distance measured in the same direction as the incident light are taken as positive and those measured in the direction opposite to the direction of incident light are taken as negative. The highest measured upwards with the heights with the respect to x-axis and normal to the principal axis of the mirror lens are taken as positive. The highest measured downloads are taken as negative. With a common expected convention, it turns out that a single formula for spherical mirrors and a single formula for spherical lenses can handle all different cases. Handle of different cases, focal length and spherical mirrors.